What's up, everyone? Hope you guys doing well. Come for the drones and stay for the delays. It's been a really long time I have made actual video because I decided wanted to make a video when I had something of a good result to show, something working. And it's been mostly I've been talking about the stuff I've been doing, but without any actual results. So I wanted to make a video when there is a really good result, and this sounded really nice thing to show you guys what I've done and the results of it. You might have seen my recent tweet about the optical flow sensor. So that's something was what I'm going to show, how it works and how to connect it and the things I've been doing with it. So this is sort of the unboxing. It's been really few weeks, I guess, since I got these board. This is the unboxing, what I did few weeks ago. And the optical flow sensor is basically a camera sensor, like a low resolution camera sensor, which takes a picture and then it verifies the position of the image. Basically it calculates the X and Y coordinate, and then it keeps making sure in the algorithm it stays 0 all the time. So basically it makes the aircraft stable. In our case, it's the drone. So it makes sure the drone stays in its place. This is basically used when there's no GPS signal or in an indoor environment. So it needs different lighting conditions to it because it's a camera. You cannot have super dark areas, but super low light is what this sensor is capable of. So this is the first sort of the board design from Agam Robotics, which has the name Agam Robotics and the logo. This you might have seen in my previous old videos, the design of it. So that's something, this board is what it is. It took almost 18 weeks with the lead time. So that's something I received a few weeks ago and I've tested it. So we'll look into that in the specific design, what I've been doing with it and what the sensor has and things like that. So this is more of a prototype board. So it's a single panel with 10 boards in a single panel. So I had 10 boards for testing. I had used up few, I think 3 or 4 sensors for now. I had rest of the sensors available. So we'll look into that. All right, as you can see here, we have the drone set up with the sensor over here. This is the optical flow sensor connected on the SPI port, and this is the sensor I've been working on. So as you can see, there is the optical flow sensor camera, and the lens comes up separately, and that needs to be glued so that you could use a Fevikwik or anything. This is the lens pieces I received. I'm not sure if you can see it. Yeah, there you go. So those are the small tiny lenses. So you had to place it in and then glue it on the outside. The sensor sort of exposes the SPI port, which is serial peripheral interface, and you have all the connections pins over here. You could solder the wires, and it also shows the direction of where the sensor needs to be mounted with respect to the aircraft or a drone. So this is X and Y, and once it places it's sort of you had to mount it bottom of the drone, so you'll be able to read the same information over here. So in this case, the drone would be mounted somewhere like this, and you'll be able to read all the sensor data, and that would sort of feed the information to the drone's flight controller. So the sensor itself is not a readily available component in the market. It's not available on DigiKey or Mouser. You need to sign an NDA with the manufacturer, where they are in Taiwan, and it took a lead time of 15 to 18 weeks to get this component. So we had rest of the component received, but we were just waiting for the sensor. It's been really long time. I think it took more than 18 weeks, I guess. So it sort of exposes all the SPI port, and the wiring is done over here. So we'll try to connect the sensor to the software, and we can read the sensor data. So I have already plugged in the other side to the computer, and you'll be able to read the sensor data from here. I'll just keep the sensor over here. And coming back to the computer, I can move this to this side. We'll have QGC, which is it's a Q ground control, which is an open source software for like setting up the aircraft, the sensors. You can like do a lot of other things. We'll like focus more on the sensor part. All right. So now that it's connected, you can see all the different sensors, everything being connected. It's all like set up for now. The sensor is not yet done. That's something I'll show you in the latest section what I've been working on. And coming back to the sensor, optical flow sensor, the ones once you saw that right now, we can go to the parameters and you can type optical flow sensor or PAW, which is the part number of the sensor. In this case, I'm using PAW 3902. So you need to make sure you click it and you enable it. Usually by default, it's disabled. You need to make sure it's enabled. Once that is done, you don't have to like change anything else. The previous sensor, what I like connected, you might have seen the previous video where the drone was flying, right? So that was a PMW sensor, which is sort of like an older version and doesn't have like low light settings. So that's this sensor. You need to enable that. If you are using that sensor, you need to enable this parameter. So right now we are just using this one. So we'll like let that go off. So once you're done, you can click this Q ground control logo and you get this tool here. Select the analyze tool and you can go to Mavlink inspector, and once you connect to the SPI, you should be able to like read the sensor of the connections, right? Like you shouldn't be having any problem once you enable it. I think probably you need to reboot the flight controller, but once you get that done, you should be able to like read the settings here. So the X and Y value, like if the drone is stable, it usually reads 0. It tries to error out and like tries to make this value 0 all the time. And if the drone is like moving, the sensor gets red and then it tries to calculate to make it stable. And this value is sort of like fed to the flight controller only when the sensor is like 0.7 meters above the ground. So if it is below that, the sensor reading might work. In this case, like it's less than 0.7 meters off the ground or like off the surface. It's reading the value, but it's not fed to the flight controller. So for it to make the drone stable, you need to have this drone or the sensor above the ground of 0.7 meters. I would say like just keep it 1 meter above the ground and you should be good to go. If you want to like test it in an environment where it is like less than 0.7 meters, I think you can go back here and search for the same settings and you should be able to read here. Like I have the camera blocking the view, so you should be able to like see the value here. So you can like set this 0.7 to whatever value you need. So that's the minimum height above the ground. And the maximum height depends on the type of the sensor. There is like a newer version, which is PAA, which I think goes up to like 30 meters or something. You might have to like check the data sheet. So the ones we are using, I think goes up to like 10 meters. So it's fairly good enough for a drone to be using an optical flow sensor. So basically that's it. What you can also do is like you can go back to the logo and then select Analyze Tools. Mavlink Console has the capability to like read the sensor values. So what you could do is like you can search this part number PAW3902 and type status. And then you should be able to like read the sensor values over here. You could like see what are the false motion report, and you could also read like how many failed events are there, and these are the different modes wherein like it switches the modes automatically based on the lighting conditions. So if it's bright, it would say it will like directly switch to bright mode, and there's like low light, and then there's like super low light. All right, so same day, different time. I just like found as I finished recording, I found like few of the things I did not like share it, like I did not update it. So the things were like, as I was like testing the sensor on the SPI, because that's the SPI port which gets exposed in the design, I found like it did not work directly. It was supposed to, but it did not. So I saw that like the SPI, in the code, right, like the SPI C++ file code, you can actually add the SPI bus on the SPI 6, which is actually unused. So I thought like I'll modify, and I did that. I was working on it, and then when I was like trying to debug through that, I found the connections were actually wrong. Like the documentation on the PX4 website was like completely wrong. Like you can go over here, you could see that the SPI wiring was found in the wrong way. Like the 5 was connected to 5 was said like do not connect, and 6, which is chip select 2, was connected to the CS pin on the sensor board. So that's what I had done before. You can see here the PR was raised. I discussed with a few of the devs on the Discord server and found like as I was testing, I found this and I noted them like it's working, but the connection needs to be reversed. So they raised the PR and it has been corrected on the documentation. Now you see the right thing here. So 5 is chip select pin on the sensor, and 6 is do not connect. So this is how it should be, and this is where it would work. So now the sensor would directly work if you have like either the latest version, which is 1.13, the firmware for PX4. You can like directly connect the sensor, and the drivers are already like there, and you make the correct connections of this sort, and it should work. Previously, the one thing I was not going towards was like I had to modify the existing code, and if anyone has to connect it, like I had to make a separate firmware for them to make sure the sensor gets connected, which was something I wanted to avoid. Now, like I'm really happy that it's actually working right off the bat. Like you just connect the sensor, make these connections, and you should be good to go. That was the whole plan. So that's something that has been fixed, and anyone who purchases the sensor should be good. Like they should be able to like connect the sensor to the drone platform, and it should work. Coming back to the product page, like the sensor is available for orders, like more of a pre-order. Right now I have like 6 sensors available from the prototype boards. You can like buy it and like test it if you want it. But if you're looking for like a bulk orders or something, you can like let me know so that I can do a complete bulk order. It may take time, like a few months. So that's depending on the quantity and the availability of the sensor. It's basically the camera sensor, which has like a huge lead time. So you can like send me an email to info@agamrobotics.com, or you can also like contact me on Twitter, or like you can notify on the YouTube comment if you're interested, or the best one is like send an email. So I have like all the information somewhat in the website. Most of the things, like I'll also make a documentation page. I'll make a separate video as well of how to connect the sensor from like the beginning, and how do you like make changes to the settings. We almost went through all those things, but I'll make a separate video just for that. Sort of like it could be like a documentation page to connect the AgamFlow sensor to any drone setup. So yeah, that's something I wanted to like let you guys know. We can continue to the next clip. All right, this works right like sort of like a plug and play system, right? Like it's directly connecting to the SPI port because it exposes that. There are some other things in the works, like I'm also working on the CAN based protocol. That's something like really better off than connecting to the SPI, because there's like only few ports available on the SPI if you have like multiple sensors, or if someone is already utilizing the SPI port, like you won't be able to connect the sensor to that port. So that's something I've been working on to use like the CAN protocol. I can like switch to this one here. So there is like the CAN port, CAN 1 and CAN 2. So that's something you can also utilize to connect the sensor, but that requires like a different design that needs to go through this. So that's something is in the works. And the sensor, what you might have seen, is the IMU board. So that's the second board I'm working on, which is in the stack. So there are like few modifications and like few problems I'm going through that. So we can like look into that further in a different video. For now, like the optical flow sensor is what I've been working on, and I wanted to like show you guys the functionality of that. Hope you guys are having like had some fun seeing the sensor working. Probably like I'll be testing the sensor on the drone, like in the field. So you might see that video later in the week. I'm like quite busy on the other part of the development, like the IMU board and the firmware of the flight controller and things like that. All right. Thanks for watching. Stay tuned for more videos. We'll like look into that. See you in the next video. Bye.